So when we go into Schoology for the review, we are in this orange unit, Unit 1A review at the bottom. Our objective today we're going to review for the test over points, lines, and planes. By the end, hopefully, we're able to identify points, lines, and planes, naming them and identifying them. Identify collinear and coplanar points. Apply the segment addition postulate. Find distance between two endpoints. Find midpoints and endpoints. And find fractional distance. I already took attendance. We're going to go through the review. And just as an FYI, I did throw together a video of keys for the independent practice. So if you were working on an independent practice and you're just not figuring out how to pass it, or you're really confused and you're still not understanding something, you can go watch this. I threw it together really quick. It is long because it's 8 independent practices. And so just fast forward till you get to the one that you need to watch, and you can watch that one. Which also means there's zero excuse for anyone not to have all their independent practices done and in Schoology, because I gave you all the answers. They're there. They do everything in Schoology. If there's anything you don't have 100 on the independent practices in Hack, remember, if you're missing anything on that first 2, you have to put them both in Schoology to get 100. The next 3, 4, and 5, that was 1 grade. If you have a 0, a 33, or a 67, you have to put all 3 of them in Schoology to get 100. Okay? The last 2 I grade checked were 6 and 7. I didn't look at 8. 6 and 7, if you have a 50 or a 0, you have to put them both in to get your 100. You should be putting them all in Schoology anyways, because that's how you know if you have the right answers. Okay? So make sure you're checking in Schoology to make sure you have the right answers. Okay? They do lock tonight at midnight. So make sure that you have anything into Schoology that you want to put into Schoology by tonight at midnight. Okay? So when we look in our packet, we can see today we're going to work on this review, and all the Schoology Unit 1 assignments will lock at midnight, and then tomorrow we'll take our test. Don't forget, on the test, it's not open notes. You do have access to a formula chart if you need one. The really only formula that you're going to need is the distance formula, and that's on the test. We made sure to put it on there for you, but if you want a formula chart, I can always give you one. Okay? And then remember, if there's anything you want to know that you don't think you're going to remember, you can always put anything on a 3-inch by 5-inch note card and bring that, and you turn it in with the test if you use it on the test. Okay? It's your responsibility to find the card and bring it, or to fill out the card and bring it. I do have some after the review. If you want one, I can give you one. Okay? All right, so let's look at the review. Let me scroll down to it. It'd be faster if I try to do that. Okay, so Unit 1A test review. I also have a calculator open, so that way when we need a calculator, I have it here available. Anytime you're on a calculator, if there's stuff there, I would always click on the home button and go home, and then press 1. We don't need to save the old stuff there. It just wastes space on the calculator, and then we want a calculator, so I'm going to pick number 1 for a calculator. Oops. Number 1 for a calculator, and then I'm ready to go. All right, so refer to the figure. Number 1 says to name a line that contains points T and P. Now, I don't even really have to look at the picture for this one, because if it goes through points T and P, then I can just call it line TP. Capital T, capital P with an arrow through it. Or PT, either way. But if I look at the picture and I see where P and T are, it's this line that's going downhill, this negative sloping line, that has a little lowercase g on the end of it. So I can call it line and then a little lowercase g. Okay? That line also has a T on it, so I could also call it line PT or TP or TN. Oh, sorry, it also has an N on it. I didn't know what the N. TN, NP, NT, right? Any combination of P, T, and N, you can pick any 2 letters. I cannot say that it's 2 opposite rays. Are there 2 opposite rays there? Yes, but that's not its name, right? That's a description of it, okay? So It is a line, even though there is a ray TP that goes this way and an opposite ray TN that goes this way, but that's not the name of the line. That's like describing it. Okay? All right, number 2, name a line that intersects the plane containing points Q, N, and P. So name a line that intersects the plane that contains Q, N, and P. So that's the gray plane, because all 3 of those points are in the gray plane. And then the line that intersects it is going to be this one that all of a sudden turns dotted. That's the one that's going through the plane. So since I have a little j at the top of that, I can just call it line, and then a lowercase j. Or I could pick any 2 points off of this line. It only has 2 points on it, M and T, so I'd have to use M and T. I could use MT or TM, as long as I put the correct notation over the line. Okay? And the last one for this figure, name the plane that contains line TN and line QR. So line TN means it goes through T and it goes through N. So that's going to be this orange line here. And line QR means it goes through Q and it goes through R. So that's going to be this green line here. So the plane that has both of those in it is the only plane I can see in that picture. It's going to be plane. Since I have this S in the corner that doesn't have a point next to it, I can use just that S to name it. If I want to use points to name it, I have to use plane, and then I have to pick 3 points that are not on the same line. So I can't say PTN, because those are all on the same line. I can't say QTR, because those are all on the same line. So I can say PRN, that would be fine. So even though P and N are on the same line, since P isn't, that's what gives me my 3-dimensional shape, is that one that's not on that line. Okay, I do want to ask you 2 other questions regarding this figure that will be helpful to know for the test tomorrow, and it's something we struggled with when we took that quiz 1, and that is going to be, are points M and Q collinear? Are points M and Q collinear? Yes or no? Here's M. Here's Q. Are they on the same line? No? What about that red dot on the whiteboard in the back of the room and that red dot on the whiteboard on the side of the room? Are they collinear? Can I put a line between them? Yes. What do we remember about 2 points no matter where they are in the whole wide world, whether we see a line or not? 2 points are always collinear. So even though in the picture I don't see a line connecting them, my answer here is yes. That's something we struggled on in the quiz. Just because we don't see it in the picture doesn't mean it can't be there. Lines, planes, points, all those things can be invisible. Okay? 2 points always make a line. 2 points are always collinear. Okay? One more question I want to ask you about this picture. Are points M, P, and R coplanar? M, I'm going to put a box around it, P, and R. Are those 3 boxes with the squares around them, or those points, coplanar? What? Yes, because 3 points, no matter where they are in the world, even though M is not in that same gray plane, I could build like a diagonal wall that would contain all 3 of those planes, or points. So yes, 3 points are always coplanar, no matter where they are. If I put a dot on my wall and Miss Ash puts a dot on her wall, and Mr. Copeland puts a dot on his wall, they're coplanar. Even though one's downstairs and the other two are upstairs. Still coplanar. Okay? All right. Moving on in our review. Refer to the figure. How many planes are shown in the figure? How many flat surfaces are in this figure? I'll give you a hint. I have a 3D representation of it right here. How many flat surfaces? 6? We have the top of the prism, of that triangular prism. We have 3 sides, right? Of that, in the mine it's purple. 3 sides of the triangular prism. And then look at the bottom of my prism. Can you see it in the 3D representation? The bottom triangle? The bottom triangle is part of the blue rectangle, right? Part of the blue plane? That's one plane. The bottom of this image, this A, B, and C, this piece here is in this plane. That's only one plane. That's only one plane. So how many planes are there? 5. Okay? How many planes contain the points E and F? So here's E, here's F. They're part of this line, 2, right? This top plane. And then this side plane over here. Both contain points F and E, or E and F. So 2. Name 4 points that are coplanar in the same plane. F what? FED. Well, that's 3 points in the same plane, but I need to name 4. So there's no other point in this top plane. So I can't use F, E, and D together. E, B, what? C, D. Yes, so if I look at this plane here, E, D, B, and C. You can write them in any order you want. I could have also used these over here on this orange side. I could have said F, E, B, and A. Or I could have used the back wall of that figure. I could have said F, D, C, and A. I got a lot going on in that drawing, though, so I don't want to try to color this. Okay? And I don't even need to look at this picture. Are these 3 points coplanar, whatever 3 points they are? Yeah. Yeah, I don't even have to look at the picture. It's 3 points. They're always coplanar. 3 points are always coplanar. Always, 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 and forever. All right, number 8 and 9 and 10, really, are all segment addition postulate. The segment addition postulate says that if I have a point on the segment, it doesn't tell me anywhere if it's a midpoint or not. If I have a point on the segment, then one side, GH, plus the other side, HJ, will equal the whole segment GJ. That sentence right there is the segment addition postulate. From there, I need to substitute in. GH I know is 23, plus HJ is X, and that equals GJ, the whole thing, 56. What do I do to solve this one? Yeah, subtraction property of equality. When I do that, what do I get X to equal? 33. And you can check it if I put it up here. 23 plus 33 equals 56. Yay, it works. Okay? The next one, same type of problem, since B is on the segment and I don't know if it's in the middle or not. Isn't this one, is H a midpoint? No. Why not? How do I know it's not in the middle? Huh? Closer to the J? I would argue it's closer to G. How far is it from H to G? 23. How far is it from H to J? It's 10 longer to get to J. This picture's not to scale. It's okay for the picture not to be to scale. But I know it's not in the middle because the two sides aren't equal, right? If this was a midpoint, these two numbers would have to be the same. So that's how I know it's not a midpoint, okay? So the answer for midpoint is not because it's in the middle or because it's not in the middle. You have to have like a mathy way of saying why it's a midpoint or why it's not a midpoint in this case. All right, same thing here. I have B on this segment. It doesn't tell me if it's in the middle or not. We'll find out in a minute. So I know that one side of B, AB, plus the other side of B, BC, is going to equal the whole segment A all the way to C. And then that's our segment addition postulate. Now we're going to use our substitution. AB is 3x plus 7 plus BC is 2x equals AC is 47. It's the first thing I should do. Yeah, let's combine these like terms on the same side of equals. 3x plus 2x is 5x. And then I still have this plus 7 here. Subtract 7. When I subtract 7, I get 5x equals 40. And then we divide by 5, and what does x equal? 8. I will say tomorrow on the test, this is super important, make sure you're reading what it asks you to find. In this problem, it does say to find x, but make sure you read, because it might say tomorrow, how long is AB? Find AB. If it says that, then I need to plug this in here and do 3 times 8 is 24, plus 7, which means AB is 31. And then over here, if it asked me to find BC, I'd have to do 2 times 8, which is 16. It's good to do it anyways, just to check 31 plus 16 are really 47. But just make sure you're reading the question tomorrow so that you know for sure what it's asking you. Is it asking you for X and you can stop there? Or is it asking you for something more? Okay? All right, number 10, given K is between J and L. So that means I'm going to be another segment addition problem because I have between J and L. And K is just somewhere in between. I don't know where. I'm going to put it off to the side because that way I don't accidentally think it's in the middle. So since it's between, I know J to K plus K to L is going to equal the whole thing J to L. And then I can substitute in JK is X plus 4 plus KL is 6. And then the whole thing is 2X. Okay? When I combine my like terms, I'm going to get X plus 10 equals 2X. What should I do next? I don't have like terms to combine. On the left side, I have an X plus 10. I can't combine those. And on the right side, I just have 2X. There's nothing to combine. Subtraction, property of equality. What do we want to subtract? The X. Let's keep our X's positive. That's going to give me 10 equals what? X, which means we're done. Again, you can plug it back in just to check your work. If I put a 10 in here, that's going to give me a 14 on this side. If I put a 10 in here, that's going to give me 2 times 10 is going to give me 20. And then if I check 14 plus 6 is 20. So it worked. I feel confident that I'm right. Look over here. Use the diagram from number 10. Find how far it is from J to K. How far is it from J to K? Since I checked my work, I already know how far it is. How far is it? 14. Whatever you do, if it says find JK, do not come over here and put X plus 4. That's not how far it is. That's an expression. Okay? How far it is 14. Okay? And then find the length. It says of KL, but they gave me that 6. And then here it says find the length of segment JL. This is a typo. It should be J. I fixed it for next year already. Okay? So JL, how far is it from J to L? We already did it because we checked our work. It is 20. Is K a midpoint?
No.
Why not?
J to K is 14. K to L is 6.
Yeah, it's closer to L, even though in my picture it's not. It's way closer to L than it is to J. This is more than twice as long as this side, right? So no, it's not a midpoint either. All right, next, one of our favorite formulas ever, the distance formula. When we do the distance formula, remember we are just filling these 4 things into our formula. Okay? So we're going to take that formula and we're going to write it, but without the 4 things that I just highlighted. So parentheses, leave a space, minus, leave a space, parentheses squared. Plus, don't forget this plus sign. I see a lot of you come up to me and show me your calculators and you have forgotten this plus sign. And then you're not sure why you didn't get the right answer. Don't forget that plus. Because remember, this is really a squared plus b squared. So you need that plus. Okay? All right, so then we're going to go and look at our points. And we're going to say, okay, here is my first point. So that's going to be x1, y1. And here's my second point. So that's going to be x2, y2. And then we just have to fill things in. What's x2? 5. What's x1? 0. Shh. What's y2? 12. What's y1? 0. All right, I can simplify this by hand if I want, but I don't have to. I can go straight to the calculator. Again, if you've never put it in your calculator, today is the last chance to do it with my help, right? So you have to hit Control, and then right next to the 4 is your x squared. That's what gives you your square root symbol. Then I'm going to type exactly what I see. I see a parentheses, 5 minus 0. Make sure you use the minus key and not the negative key. That will give you the wrong answer if you use the negative. 5 minus 0, close the closed parenthesis is already there, but you have to hit it just to move to the other side of it, or you have to hit the right arrow to move to the other side of it. Squared, don't forget the plus sign. Parentheses, 12 minus 0, use the minus, not the negative. Oops, minus, don't do that. I didn't want that square there. 12 minus 0, close parentheses, and square. And then just kind of double check there and there, make sure they're the same. What is my distance? 13. All right, number 13, again, we're going to do the exact same process. So I'm going to write my distance formula without the 4 variables in it. Parentheses minus parentheses squared plus parentheses minus parentheses squared. Don't forget that plus sign. Don't forget the squares. And then I'm going to label my picture. So I've got my first x and my first y. I've got my second x and my second y. Not a very cute y. That's okay. All right. What's going to go in my first space here? 2. What's going to go in my second space? I already have a minus here. Do I have to put the negative? Yes. Good. Always. What goes in this blank? 7. What goes here? Do I need the negative? Yes. If you want, when you put this in the calculator, what can you do here? Yeah, turn them into plus signs when you put them in your calculator. It's 2 less buttons you have to push. So Control, square root, parentheses, 2 plus 3, or you can do 2 minus the negative. You have to use the minus key for the minus and the negative for the negative, or it will be wrong. Close parentheses, squared. Don't forget the squared. Don't forget the plus. Parentheses, 7 plus or minus a negative 1. Close parentheses, squared. When I do that, I get a distance of 9.43398. In this class, because we're trying to practice for someday when we're taking an AP course, they're going to always ask you to round to 3 places. So if it doesn't tell you what to round to, it's always good to just practice rounding to 3 places, which means after the decimal point, we go 1, 2, 3. Look at the 4th one. Do I need to round up?
Yes.
Yes, it's 5 or bigger, so we need to round up. So my distance is going to be 9.434 units. All right, for number 14, I showed you kind of like a trick way to do it. For here in this review, we're going to do it algebraically. To find the midpoint, you have to average your x's and average your y's. So you're going to average your x values, and then you're going to average your y values. Okay? So when I start with my x's, I've got a 1 and a 6. If I'm going to average 2 numbers together, you add them together and divide by how many there are. There's 2. So we're going to divide by 2. So my x is going to be 1 plus 6 divided by 2. Oops, I don't want to close parentheses there yet. What's 1 plus 6? 7. And 7 divided by 2, you can either leave as 7 halves, or that's a 7, by the way, and that's a 2, or you can change it to 3.5. They're both correct. Because 3.5 is a nice even decimal, like it doesn't keep going forever and ever. Okay? All right, then we're going to do average the y's. So my 2y values are 2 and negative 6. So I'm going to add them together, 2 plus a negative 6, and divide by 2. 2 plus negative 6 is negative 4 over 2, negative 2. Very good. All right, so that is the midpoint. Make sure it's not in the review, but make sure you know how to find an endpoint. Also. Okay, so if you're given one end and a midpoint, you need to be able to find the other endpoint. All right, the next one, find the point that is 1/3 the distance from 1, 1 to 10, 3. All right, so if I were going to graph that, okay, everything's positive, so I'm just going to do this part of the graph. 1, 1 would be real close to the axis, right? This is 1, and this is 1. And then 10, 13 would be like 10 would be way over here, and then 13 would be way up here. So 10, 13 would be like here. Okay? So I'm trying to find the distance that's 1/3 from that bottom point going towards that top point. Remember, we have to do the process twice, once to find our x value and once to find our y value. The first thing we do to find our x value, I'm going to say find x. The first thing we're going to do is we're going to move our points down to the x-axis, here and here. And I'm going to say, how far is it from one x to the other x? If I'm at 1 and then 10, how far is that? 9, okay? And then I want to find 1/3 of that. So 1/3 of 9 is what? 9 over 3, which is 3, okay? All right, it says I'm going from 1, 1. So that means I'm starting here at the 1, and I'm going across the x-axis. So am I adding or subtracting? Adding. So I'm starting at 1, and I'm adding, how much am I adding? 3. What's my value for x? 4. That's x. All right, now we're going to find y. First thing we do is we take our points and we move them over to the y-axis, here and here. How far is it between those 2 points if I'm at 1 and 13? 12. And then remember, we're trying to find 1/3 of that. What's 1/3 of 12? 12 over 3, which is 4. Okay? So I am starting, it says from 1, 1. So I'm starting down here at 1. And I'm going up to 13. So I'm starting at 1, and am I adding or subtracting? Adding. How much am I adding? 4, which is going to put me where? 5. That's my y value. So that means the point I'm trying to find is the point x is 4, y is 5. 4, 5. All right, only a handful more problems. Number 16, draw and label a figure for each relationship. It says point K lies on RT. So that means I have line RT because I have arrows on both ends. So it's a line. Can I just put an R there and a T there? Do capital letters label arrows? What do capital letters label? Points or planes. I don't have a plane here, and I haven't drawn any points. Oops. How'd I end up way up here? So I have to draw points on that line. Okay? I have to have points. Wherever you want to put them, it doesn't matter. R, T. Point K needs to be on that line. Does it matter where it is? No, anywhere you want to put it. To the left of R, in between the two, to the right of T, wherever. It doesn't matter. You can put it wherever you want. You can put it there. You can put it over here. You can put it there. Anywhere. As long as it's on that line. All right. Plane. Will somebody grab the door for me, please? Plane J contains line S. And notice there's a little lowercase s. That's the one that does go by the arrow because that's the actual name of the line. Okay, so it's easiest if you draw the plane, for me anyways, if I draw the plane first. Remember, we just draw, it looks like a parallelogram. And it's plane J, so that means in one of the 4 corners, whichever corner is your favorite, put your J. I, for some reason, tend to typically put it in the lower left-hand corner when I draw them. I don't know why. And then when it says it contains, that means the whole line has to be inside the plane. So when you draw it, it can't go outside of what we just drew. You can draw it going uphill or downhill or wherever you want, or even just horizontal, however you want to do it. And then by one of the arrows, it doesn't matter which one, you put your little lowercase s. Number 18, line YP lies in plane B and contains point C, but does not contain point H. So line YP is doing lots of things. It's in a plane. It has a point on it, and then this other point is not on it. Okay? So the first thing I'm going to do is I'm going to draw the plane because I need to make sure the line's inside the plane. Plane. This is plane B. You can put the B in any corner you want. This line has to be inside it. Don't let your arrow go outside your plane. This line is YP, which means it has to have a point called Y on it. It has to have a point called P on it. This line is in the plane, and this line contains point C. So somewhere in this line, wherever you want to put it, you got to have a point C. And this line does not contain point H. So I can put point H anywhere in my whole review that I want to put it, as long as it's not on this line. So it can still be in the plane. I could put it here, because then it's not on the line. Or I could put it, if I want to be really safe, I could just put it way over here And it's definitely not in the line. It's not even in the plane. Okay. All right, and number 19, lines Q and F. It's a lowercase q, that means it's the name of the line, not a point. And F is a lowercase f, so it's the name of the line, not a point. These two lines intersect at point Z in plane U. So I'm going to draw plane U. For me, it's just easier to draw the planes first. Plane U. And then here it doesn't tell me that the lines have to be in the plane. It just says they have to intersect each other at point Z, and point Z has to be inside the plane. So I could draw one line in the plane and the other one going through the plane and hitting that line at point Z, but I'm not trying to be all fancy. So I'm just going to put both my lines in the plane. So I'm going to put one in the plane going uphill, and I'm going to put one in the plane going downhill. I'm going to put a little Q on the end of one and a little F on the end of the other, and they intersect right here at a capital Z. Again, you could get much fancier than that if you wanted to, but there's no need to. All right, last question. During practice, Astros player Altuve throws the baseball to Pena, and he throws it back. If Altuve is standing at 5, -1, and Pena is standing at the point -2, 4, what is the total distance the baseball has traveled if Altuve throws the ball 2 times? All right, so when I look at this one, okay, Altuve is here at 5, -1. Pena is up here at -2, 4. I need to figure out how far they are. How far is he throwing the ball when he does this? So that's going to be distance formula, where I've got 1 point and a second point. My distance formula is distance equals the square root of x2 minus x1, close parentheses squared, plus, please stop talking, y2 minus y1, close parentheses squared. So distance equals the square root of parentheses minus parentheses squared plus parentheses minus parentheses squared. And then what am I going to put in place of x2? -2. What about x1? 5. y2? 4. y1? Do I have to put the negative? There's already a minus. Yes. Okay, put that in the calculator. Square root of parentheses negative, make sure you use the negative, 2 minus, use the minus, 5, close parentheses squared, plus parentheses 4, I'm going to do plus instead of minus and negative, 1, close parentheses squared. Is this my distance? 8.60233. That's how far it is from Altuve to Pena. But what does Pena do after Altuve throws it? He throws it back. So that means the ball is going to go back again. But wait, there's more. How many times does Altuve throw it? Oh, so he's going to throw it again. And Pena's going to do what? Throw it back. So what do I really need to do with this number? I need to multiply it by 4 times 4. It takes that last answer that's in the calculator times 4. My answer really is 34.409. After the 9 is a 3, so I'm just going to round it to 3 decimal places for my answer. Your test is tomorrow. Don't forget your assignments in Schoology. Everything locks at midnight.